interesting line that is transversal. So what is transversal? So it is a line that intersects two or more lines at distinct points. That's interesting. So why do we call it a transversal? Okay, first let's see what is it like. It is like, let's say you have two different lines like this. Doesn't matter whether they are parallel or they are intersecting, doesn't matter. Let's say you have two lines, and if there is another line which intersects two lines at distinct points, at different points. So it is intersecting the first line at this point and it is intersecting the second line at this point. So this line is called a transversal. Now a transversal necessarily does not intersect two lines. It can intersect 2 lines, 3 lines, 5 lines, 10 lines, or even more than that. So basically a line that intersects multiple lines at distinct points is called a transversal. Now, why is it called transversal? Now, the word transverse, it literally means cutting lines or to lie across. Now, when you look at this, you see this transversal lies across these two existing lines. So that is why the name has been given as transversal. So let's say that you have 3 lines which are again not parallel, they are all different directions. But if you could somehow draw a line which is intersecting all the 3 lines at 3 distinct points, then this line would be called a transversal again. Now, the transversal, whenever it intersects multiple lines, certain angles are made. So let us look at those angles made by transversal. So let us look at the various angles that are formed. So you see, when this line cuts these 2 lines, so many angles are formed, right? So these are all the angles that are formed. So let us name these angles. Interior angles. So what are the interior angles? Now, even before that, let us start naming the angles. Now, the angles which are formed in the inside of the 2 lines. So here, inside would mean this region. Right? So this part would be inside and this part would be outside. So this would be inside and these would be outside. Similarly, these would be outside. So inside the lines means the area which is there, which is included within the lines, and anything outside that would be outside. So interior angles means the angles which are formed in the inside of the lines. And definitely these angles are made by transversal. So the transversal has to be one arm of the angle. So this angle, let's call this angle 1, this angle 2, this angle 3, and this angle 4. So these are all examples of interior angles. So angle 1, 2, 3 and 4 are the interior angles. Similarly, the exterior angles which are formed are those which lie on the outside. So basically these angles, let's call them 5, 6, 7 and 8. So these are exterior angles, angle 5, 6, 7 and 8. We also have a pair of corresponding angles. Now, what are corresponding angles? Now, these are those angles which are located at corresponding positions related to the 2 lines. Let's say if you compare angle 3. So, angle 3 is located on the right hand side of the transversal. Now, at a corresponding position for this line, do you have an angle? Of course, you have angle 5. So when you look at the position of angle 3 on this line and the position of angle 5 on this line, you see that they are located at similar positions. They are on the same side of the transversal. They are located above the line. So in this case also, this angle is located above the line. Here also the angle is located above the line. Correct? So we can say that angle 3 and angle 5 are a pair of corresponding angles. Similarly, can you tell me which would be the corresponding angle for angle 7? Yes, angle 1. So angle 7 and angle 1, they also form a pair of corresponding angles. Similarly, what would be the corresponding angle for angle 2? So for angle 2, it would be angle 8. So angle 2 and angle 8 also form a pair of corresponding angles, and finally angle 6 and angle 4 also form one set of corresponding angles. So these are called corresponding angles because they are located at corresponding positions relative to the two lines. Next we have alternate interior angles. So these are also interior angles, but they are alternate interior angles. For example, anyways we have four interior angles, right? 1, 2, 3 and 4. So alternate interior angles would be two interior angles which are located on alternate sides of the transversal. For example, angle 2 is located on the left hand side of transversal, angle 3 is located on the right hand side. So 2 and 3 are located on alternate sides. So you can say that angle 2 and angle 3 form a pair of alternate interior angles. Similarly, angle 1 and angle 4 form a pair of alternate interior angles because these are also located on the interior side and they are located on alternate sides to each other. Similarly, when you look at pair of alternate exterior angles, so definitely you will deal only with the exterior angles. For example, what would be the alternate angle for angle 5? So the exterior angle which is located on this side of the transversal. So angle 5 and angle 8 would form a pair of alternate exterior angles. Also angle 6 and angle 7 would form a pair of alternate exterior angles. Finally, you would also have pair of interior angles on same side of the transversal. So interior angles can be alternate, like 2 and 3 are alternate interior angles, but 1 and 3 are interior angles on the same side of transversal. So angle 1, angle 3, they are interior angles on same side of transversal. Similarly, angle 2 and angle 4 are also interior angles on same side of the transversal. So you see, these are all angles which are formed by the transversal and they have been given different name based on their positions. Parallel lines, because when we draw a transversal on parallel lines, we see that a lot of relationships between these angles which we discussed just now establish. So whenever two parallel lines are intersected by a common line, so that common line is called the transversal. Now in case of parallel lines, these are the following relations that establish. That is, it is observed that the pairs of corresponding angles are equal. So you remember we spoke about the corresponding angle. So let's say if this is angle 1 and if this is angle 3. So these are corresponding angles. So as per this relation, angle 1 is equal to angle 3. Similarly, let's talk about this angle. Let's say that this is angle 2. And let's say this is angle 4. So angle 2 and angle 4 are also corresponding angle. So angle 2 is equal to angle 4. Similarly, if this is angle 5 and this is angle 6, so 5 and 6 being corresponding angle 5 is equal to angle 6. So a pair of corresponding angles are always equal. Second, pairs of alternate interior angles are also equal. Now which are alternate interior angles? In this case, angle 2 and angle 3 are alternate interior angles, right? So angle 2 is equal to angle 3. Similarly, which is the alternate interior angle for angle 5? This angle, let us call this 7. So angle 5 is equal to angle 7. Now these relationships hold true only in case of parallel lines, only when the transversal is intersecting parallel lines. Pairs of interior angles on the same side of transversal are supplementary. Now, which are the interior angles on same side of transversal? Maybe angle 5 and angle 3. So as per this, angle 5 plus angle 3 is equal to 180 degree. That is, these are supplementary. Similarly, angle 2 plus angle 7 is equal to 180 degrees. So these are certain relationships which hold true for transversal intersecting parallel lines. Now that's important. Now you might wonder that why is it that suddenly for parallel lines so many angles have become equal, like the corresponding angles became equal, alternate interior angles became equal. So in order to understand that, we will prove each of these facts one after another. So let us first try to understand why the alternate interior angles are equal in this case. Now, we basically want to prove that y, let's call this as angle maybe 1. Let us call this angle 2. So we basically want to prove here that why is it that angle 1 is equal to angle 2. So we want to understand why this is true, right? Now, there is definitely a mathematical proof to verify why angle 1 is equal to angle 2. However, that proof will involve congruence theorem, which you will learn in your higher classes. So that mathematical proof you will learn when you go to your class 9th. But for now, I want to explain you that why this relationship holds true for only parallel lines and not for non-parallel lines. So we will have a look at it. Now, just looking at this diagram, let us mark these angles also. Let us mark this as angle 3 and let us mark this as angle 4. Now, looking at this diagram, you can say that angle 1 and angle 3, they together form supplementary angles. They form a linear pair. So, angle 1 plus angle 3 is equal to 180 degree. Similarly, you can say that angle 2 plus angle 4 is also equal to 180 degree. So from these two, you can say that angle 1 plus angle 3 is equal to angle 2 plus angle 4, right? Now we also know that angle 3 is not equal to angle 2, right? Because looking at this, you can very easily see that if this is an obtuse angle, then this is going to be an acute angle. Similarly, when this is an obtuse angle, this is going to be an acute angle. Looking at the diagram only, forget about the relationship. When you look at this diagram, let's say that these two lines are parallel. So if you draw a 90 degree like this, similarly if you draw a 90 degree like this, what do you see? You see that angle 2 is greater than 90 degree, and here you see that angle 3 is less than 90 degree. So that is how it is. So we know that angle 3 and angle 2 will never be equal. Similarly, angle 1 and angle 4 will never be equal, because in both of these cases, if one angle is acute, the other angle is obtuse. So they both can never be equal. So for in this relationship, when you look at this relationship, this angle 3 and angle 2 will never be equal. Similarly, angle 1 and angle 4 will never be equal. So the other possibility that is left out is angle 1 can be equal to angle 2. Similarly, angle 3 can be equal to angle 4. Now, there is also a possibility where you might say that, okay, it is also possible that none of these are equal to each other, but still their sums are equal. Yes, that is also very much possible. But in this case, what I am trying to show you is mathematically we get certain hints that there is a possibility that angle 1 can be equal to angle 2. Similarly, angle 3 can be equal to angle 4. Now, the question is, what goes wrong in case of non-parallel lines? Now, in case of non-parallel lines, let me draw non-parallel lines. Let's say these are non-parallel lines. When we draw a transversal, what happens is, here, let's say this is the angle, and here this is the angle. So if this angle is obtuse, this angle becomes acute. Do you know why? Because this line itself is moving in the upward direction, right? Because the two lines are trending to meet each other. Therefore, what happens? The orientation changes, that is the angle changes. Therefore, here this angle is acute and this angle becomes obtuse. Similarly, if let's say that if two lines are moving away from each other, in that case, here the angle would be acute, but in this case, the angle would be obtuse. So, whenever you consider non-parallel lines, their alternate angles will change. In a similar way, their corresponding angles would also change, and the sum of the angles on the same side of transversal would also change. So, this entire relationships, they develop just because the two lines are parallel. When the two lines are parallel, this equality of the angles hold true. So let us